Welcome back, Marauders. This video 8.6, we're looking at resonance structures. So sometimes when you're drawing a Lewis dot structure, it's not possible to draw one Lewis dot structure that completely represents the bonding in that molecule or ion. So we're going to look at a few examples today and how we can use resonance structures to show that the best structure is maybe not represented by just one picture, but kind of an average of two different Lewis dot structures. So the first example we'll look at is O3. So when we look at O3, we have 6 valence electrons from each oxygen. So we have a total of 18 valence electrons. And so we have an oxygen in the center and then 2 oxygens on the sides. And so we have 18 electrons. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this Lewis dot structure with a single bond and a double bond shows how all of the oxygens could get an octet. However, I could have just as easily drawn a Lewis dot structure where the double bond was on the left side rather than the right side. So this Lewis dot structure looks very similar, but I switched the positions of the double and single bonds. And so when I'm drawing a Lewis dot structure for O3, what I'm going to do is draw both of these and then an arrow in between to show that it's not really this Lewis dot structure fully representing ozone. It's not really this one, but it's a blending of the two. So it's important to understand that it's not like some of the molecules look like this and some molecules like this look like this. It's not that it flips back and forth between the two, but it's that it's an average of both. So both of these bonds would have the same length. Both of these bonds would have the same length, and they'd both be somewhere in between the strength of a double bond and a single bond, and somewhere in between in length of a double bond and a single bond. You can sort of think about it as each one of these being a 1.5 bond. So you can think about it, you don't really want to draw it like this, but you could think about it as something like this, where each one of the bonds are the same, and they're each like 1.5 pairs of electrons being shared. But we don't draw it like this. The way we represent it is by drawing the two separate Lewis dot structures, where you can see that this is kind of like a single bond, kind of like a double bond, or halfway in between. Same thing on the bond on the right, kind of like a double bond, kind of like a single bond. It's like the strength and the length of a 1.5 bond. The next example we were going to look at was NO3 with a -1 charge. So here we have 5 electrons for the nitrogen. We have 6 for each of the oxygens, and then 1 extra because it's an ion. So this would be 24 electrons. So we have the nitrogen in the center, and then we have it attached to the 3 oxygens. And so that's 6 electrons, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this would be a Lewis dot structure for the ion NO3 with a -1 charge. And we can see that in this structure, all of the oxygens got an octet, and so did the nitrogen. But I chose to put the double bond here. I could have just as easily put it here or here. So in reality, this doesn't have 1 double bond and 2 single bonds. In reality, it has a blending of 3 different resonance structures. So I need to draw 2 more structures. So I'll try putting the double bond up here at the top. And then I'll draw 1 more resonance structure where the double bond is over here. And so we can't draw just one Lewis dot structure to totally show the bonding in this molecule or this ion. We have to draw 3 separate ones and then put the arrows in between to show it's a blending of the 3. So this first bond right here, it's not really a single bond, but it's a single bond blended with a single bond blended with a double bond. So it's a combination. It's somewhere in between a single and a double bond. And all 3 of the bonds in this molecule are a blending of single bonds and double bonds, so they're somewhere in between in terms of length and strength. The last example I wanted to show was benzene C6h6, and so this is a molecule, an organic molecule that forms a ring of carbons like this, and then there's 1 hydrogen attached to each of the carbons. And then in order for us to get an octet, we have to put double bonds between some of the carbons. I put it between these carbons, but I could have just as easily put it between the other carbons. So benzene is kind of a common organic molecule, and so it's one that you may want to be familiar with. And it's has resonance structure so that we don't really have double bonds and single bonds going around this ring, but we have two different resonance structures to show that this bond right here at the top is not really a single bond, not really a double bond, but it's a blending of the two. So it's somewhere in between in terms of length and strength of the bond.